Alright, continuing with our video sequence, we're going to now look at how to do the while loop in Java. So this is a pretest indefinite loop, and we should use it when there's a chance that we don't want the code in the loop to run at all. So it tests the condition before the loop executes. Also, this is a kind of indefinite loop, which means we don't know how many times it'll run. So it's appropriate when we know that. When you know how many times things are going to run, like you want to do something a certain number of times, then use the for loop. Okay, I decided I'd go ahead and write this one with you for reinforcement, and I'm actually going to use a sample program from the book, although I'm going to do it slightly differently. So the basic idea here is we want to write a program that tells us how many years it will take for our investment to double given a certain interest rate and a certain initial balance. So let's go ahead and kind of write out our pseudocode here. And basically the idea is we want to calculate the interest and then add the interest to the balance, and we want to do this as long as the total doesn't meet our target. So basically we'll say while balance is less than target. Okay? Now, of course, I can write this in code, so right now I'm writing in pseudocode for you. So while balance is less than target, calculate the interest, add the interest to the balance, and then we need to keep track of each year. So that's like a counter. So each year that we add the interest on, we'll have to increment the year. So increment the year total. And then basically this is the end while. So I'm actually going ahead and writing the pseudocode out like we learned to do, and I'm going to translate this into Java. So the first step here is, what kind of variables do you think we're going to need? So I need one for initial balance, and when we do currency, usually we use double for variables. So we'll call this double and then initial balance. Now, before I write this, I want to mention something I haven't shown you before. When we have values that don't change, we call those constants. And there's a nice way of doing that in Java. We use the final keyword. So if I say this variable is final, it's going to never change. And the convention when I do these kinds of variables that are constants is to write them in all uppercase letters. So this is going to be final double initial underscore balance. And one of the reasons we do this is that I can see this in the code, that it's a constant that will never change. One thing you should never use are called magic numbers. So here my initial balance is going to be $10,000. And I could just put the 10,000 right in the code as a number, but that would make the code less readable. So basically you don't want to ever have magic numbers in your code. Instead, use these this mechanism for creating these symbolic constants. So that's a symbolic constant called initial balance. It has a value of 10,000 and it'll never change. Okay, we're going to need to have a rate of interest, and this will never change either, so that'll also be final. So interest rate, we could just call this rate. Let's do that. Although interest rate is probably a better name, it's more specific, it'll be fine. Whoops, I'm getting ahead of myself, aren't I? So final double rate equals Now, what Cay does is he uses an integer here, and then he divides it by 100 to make it a percent. I think that's kind of screwy. So 5% is going to be 0.05. So we'll go ahead and use a floating point number, and we'll use that in our calculation. Okay? All right, we need a balance. This will also be double, but it'll change, so it can't be a constant. So double balance equals, and we could go ahead and set the, let's see, instead of setting this to 0, I'll just go ahead and set it right away to the initial balance. So initial balance. You can see that I could have just said balance equals 10,000 here, right? But it's better not to do that. So I'm using, instead of having the magic number, I'm using the symbolic constant. Okay? All right, what else are we going to need here? Okay, we have to keep track of the year total, and that's going to be an integer because that doesn't have a fractional part, right? So int years, let's call it year total, and we'll set this to 0 initially so we don't, and again, that's not a constant because that'll change, okay? Again, I like to put all of my variables at the top. I'm not sure why Cay did this. In this particular example, he actually declared a variable in a loop. I never do that. I don't think that's a smart thing to do. So basically, let's go ahead now and write the code out. So the way the while works is that, oh, we have to do our target. I forgot. Now, is our target going to change? No, so that can be a symbolic constant as well. And so that'll be final double target. And this is going to be basically double our initial balance, right? So we'll write that in terms of our symbolic constant, initial balance times 2. Now remember, I could have just put 20,000 in here, but again, that's a magic number. We want to avoid that. It makes the code much easier to read if we do that. Okay, let's go ahead and start to do our loop. And again, I'm just going to write the loop right into the pseudocode as comments. Usually these comments aren't going to be quite this detailed, but as we're learning Java, it's not a bad idea to make them that. So the syntax for the while loop is while, and then in parentheses, the expression, and the loop runs as long as the expression is true. So here we want to run the loop as long as the target is, as long as the balance is less than the target. So while balance is less than target, all right, then we have to create a loop body. And remember, in our pseudocode, we have while and then end while. And in Java, there's no end while. That's just the end of our block. So here are the things that are going to happen in our block. Okay? So how do we calculate the interest? Oh, you know what? I forgot a variable for interest, didn't I? And that'll be a changing variable rather than a constant. So let's put that in. Double interest. And initially, interest equals 0. Okay? All right, so calculate the interest. So the interest is equal to the current balance, the balance that is, times the rate. All right, and whoops, rate is a constant, so it should be written like that. Okay, and then the next statement in our pseudocode is add the interest to the balance. So that's going to be balance equals balance plus interest. And there's actually a nice way of writing that in Java, which is this. balance plus equal interest. So this is shorthand in Java. Okay, now I don't want to do this twice, so I'm going to comment this out, but I'll leave it in the code for you so you can see. So this is the shorthand. Plus equal means take the balance and add the interest to it. Okay, and this means the same thing. Balance equals balance plus interest. So that says take what's currently in the balance and add the interest to it, and then assign it back to balance. So it increments the total you already have. Okay? All right, and then we want to go ahead and increment our year total, and this would be year total. And again, I could say year total equals year total plus 1. That's the longhand way of doing that. But there also is an even shorter shortcut when we add 1 to an element. And we do that all the time, so Java has a shorthand for that. So we're going to do that, year total plus plus. And now you know where C++ comes from. I'm joking. Okay, so basically at the end of the loop, we know how many years. So let's go ahead and put in an output statement, SOUT tab in NetBeans. Total years to double investment is, and then we'll put a space, and then we'll display the year total variable. Okay, does that look good? All right, let's see what's going on here. Okay. When I have this text up this high, it does roll over, and I'm trying to keep it on the screen for you. Okay, so again, that matches the class, that matches the main, that matches the while loop. You can see I don't have any red ink here, so I'm good, so I can run my program. So let's run our program and see what we get. And this is pretty readable. It looks like it remembered that I wanted this to be larger. So total years to double investment is 15. You know, we could make that read a little bit better. It's always good to make it pretty output and very clear prompts when you do the input. So I'm going to come on over here and just to add the word years on here. So plus space years. And we'll use good English, so we'll make that a complete sentence. Whoops. Sorry about that. I got a little confused. There we go. All right, run it one more time just to look at our new output. There we go. Total years to double investment is 15 years. By the way, you could argue that this is not the way to write this particular program. So this is sort of artificial in that I wanted to show you how to use a while loop, and I used this method. We could easily calculate the number of years without using the while loop. And the reason I mention that is there's more than one way to skin a cat. And so when we look at approaches to solving problems, we call those algorithms. Sometimes one approach is more efficient than another. So if you can just calculate something directly with a formula instead of using a loop that repeats, in this case 15 times, that's a lot better approach. So we could argue that that would be a better algorithm than we're using here. The whole point here is to show you how to do the while loop. So let's just review. We have the while loop. In parentheses, we have a conditional statement, which can be a Boolean variable or a Boolean expression like I have here. That's going to evaluate true or false. If it's true, then we run all the statements in the loop body, going back up to the top, and test again. To make sure that we don't have an infinite loop, the variable that we're using for the control in the expression has to be changed in here. So you can see that this starts out as true because it's less than the target. If there's no code in here to increase this to eventually make it greater than the target, we have an infinite loop. That's a mistake. The loop and the program will never stop. The loop will continue. Okay? And so that's what controls the loop. This particular style of loop tests at the very beginning. It's called a pretest loop. It's called an indefinite loop because we don't know ahead of time how many times it'll run. Although actually, you know, with this particular thing, you don't really need a loop at all, as I talked about. Okay? So if this actually turns out to be false at the very beginning, none of the code in the loop works. With the do while loop, the test is down here at the bottom, and that loop always runs the code in the block at least one time and then checks after it runs. And so if it's false at the very beginning, it'll run one time and then it won't repeat. This loop checks first. It might not ever run the code if it's false. Excuse me. If it's false at the beginning. All right, I hope you're enjoying these little videos and that they're helpful. Usually I do a similar thing in class, and so if you miss class, you can use them, and I'm hoping eventually these will be rich enough that people will learn how to do this stuff on YouTube without having me in class. That'd be fantastic. All right, take care and keep on coding.